Students, welcome to Young India Math Summer Course Class 3. So in this class, we are going to discuss about prime and composite numbers, LCM and HCF, and divisibility rules for the digits. So before knowing what are prime and composite numbers, we should know a term known as factors and multiples. So to explain you what is meant by factors, let me take a very small example. Let me take a number 12. So how can I write 12? I can write 12 as 1 into 12. I can write it as 3 into 4. I can write it as 2 into 6. So if we see here, this 1 here is known as divisor. This 12 is known as quotient. This 12 which you see here, that is known as dividend. And this 0 is known as remainder. So these are the basics of division which you all are familiar with. So whenever if you do division and you get the remainder as 0, then this divisor and the quotient are said to be the factors of the dividend. Now you need not get confused. If you take the example which I have written over here, 12 is equal to 1 into 12. It can be written as 3 into 4. It also can be written as 2 into 6. So all these numbers which are there, 1, 12, 3, 4, 2, 6, they are all the factors of 12. So if you see here, the factors of 12 are 1, 2, 3, 4, 6 and 12. Always remember that 1 is a factor of every number, and also that number itself is also a factor of itself. So students, for your better understanding, let us take one more example. 6 can be written as 1 into 6 and 6 can also be written as 2 into 3. So here the factors of 6 are 1, 2, 3 and 6. As I told you, 1 will be a factor of every number, and that same number will also be a factor of that number. So you might get a doubt how to find factors. It is very simple. If I take 24, I can write it as, so if you just see here, I have taken 24 is equal to 1 into 24, 2 into 12, 3 into 8, 4 into 6. So if you just see here, you can just take all these numbers. I have written 1, I have written 2, I have written 3, 4, 6, 8, 12 and 24. As I already told you, 1 is a factor of every number and 24 is also a factor of every number. So what you need to do to find factors is, you need to make sure that you write all the, like how they are divisible. For example, you can write 1 into 24. So like that you need to write all of them, and in this way you can find factors. I hope you are clear with factors. Let us move on to what is meant by multiples. So what is meant by multiples? Multiples are nothing but if you take any number, if you multiply, for example, I am taking the number as x. If I multiply x into 1, it is a multiple of x. If I multiply x into 2, that is a multiple. If I do x into 3, that is also a multiple of x, and it will go as so on. For your better understanding, I have taken an example over here. That is 12. If you do 12 into 1, we will get 12, which is a multiple of 12. If I do 12 into 2, I will get 24. 24 is also a multiple of 12. If I do 12 into 3, I will get 36. 36 is also a multiple of 12. If I do 12 into 4, I will get 48. So 48 is also a multiple of 12. So if you write the tables like 12 into 1 is equal to 12, 12 into 2 is equal to 24, 12 into 3 is equal to 36, 12 into 4 is equal to 48, and so on, it will go so on. These numbers which are there, the answers that you get are the multiples of this 12 number. So 12, 24, 36, 48, all these are multiples of 12. So let us see the multiples of 6. If you do 6 into 1, 6, 6 into 2 is equal to 12, 6 into 3 is equal to 18, 6 into 4 is equal to 24, and so on. All these numbers which are there are multiples of 6. Very simple. So 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24, 6 fives are 30, 6 sixes are 36, 6 sevens are 42, and so on are the multiples of 6. Now let us move on to the topic that we want to discuss here, that is prime and composite number. So first let us see what is meant by prime numbers. Prime number means any number that has its factors. Any number that has its factors as 1 and the number itself is known as a prime number. I know you will be confused if I tell you in the form of definition. So let us move on to some example. So if you take the example of 2, 2 can be written as 2 into 1 and it cannot be written as anything else. It cannot be written as anything else. So the factors of 2, the factors of 2 are 1 and 2. So as I told you, any number that has the factors as 1 and the number itself, it is known as a prime number. So if we take the case of 2, it has 1 as a factor and also the number itself, means 2 as a factor. There are no other factors than 1 and 2 for 2. So we can tell 2 as a prime number. Why? Because it has 1 and 2 as its factors. For example, if we take 3, we can write 3 as 3 into 1. Here, the factors of 2, the factors of 3 are 3 and 1. So, the number itself is a factor and 1 is a factor. So, I can also tell 3 is a prime number. So, any number that has 1 and the number itself as their factors, then they are known as prime numbers. Okay? Coming to the composite numbers, any number that has more factors, means for example, if I take 6, I can write 6 as 1 into 6. I can write it as 2 into 3. Here we can tell the factors of 6 are 1, 2, 3 and 6. So here if we take 1 is a factor, 6 is also a factor. But if you just see 2 and 3 are also the factors of 6. So 1, 2, 3 and 6 are the factors of 6. So whenever any number has more factors other than 1 and the number itself, here you are having more factors, that is 2 and 3. That is known as a composite number. If you take 12 for example, 12 can be written as 12 into 1. It can be written as 6 into 2. It can be written as 3 into 4. So the factors of 12 are 1, 2, 3, 4, 6 and 12. By this, what you can understand is 12 has more factors. That's why 12 is also a composite number. If you just see here, the numbers that are present here, which are highlighted in yellow color, are the prime numbers. If you take 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97 are the prime numbers from 1 to 100. These are the prime numbers. So in total, we have 25 prime numbers from 1 to 100. If you count all these, you will get 25. So other 75 numbers are the composite numbers. Once again, I am telling you, prime number means any number that has 1 as its factor and the number itself, the same number as its factor, is known as a prime number. Any number that has other than these is known as composite number. It will have more than 1 and the number itself. That is known as composite number. Now coming to our next topic, let us see what is meant by LCM and HCF. So the full form of LCM is least common multiple. We have already discussed what is meant by a multiple. So now let us discuss what is meant by LCM. For this, I will take an example for you. So I am taking an example here where I am taking 6 and 12 as my first example. If you just see, I am taking 6 and 12 as my first example. Here, to find the LCM, what we have to do? I am going to first take the common things. So here what I have done, I have written the multiples of 6 and 12. What is meant by multiples? If you just multiply 6 into 1, 6 into 2, 6 into 3 and so on, you will get the multiples. So I have written here, if you see here, I have written 6 into 1, 6, 12, 18, 24, 30, 36, 42. These are the multiples of 6. And I have also written multiples for 12. What I am going to do now is, I am going to take common numbers from this, the common multiples. So, 12 is a common multiple, 24 is a common multiple, 36 is a common multiple. So what I am going to do now is, I have told that LCM means least common multiple. Least common multiple. So here, what is the least common multiple? 12 is the least one. First, what I told you, you have to list all the multiples of 6 and 12. So I have listed all the multiples of 6 and the multiples of 12. Next, we have to take the common multiples. Then, after taking the common multiples, I have to check the least one. If you see, the least here is 12. So here, for LCM of 6 and 12 is 12. Because it is the least common multiple. It is the LCM. Okay? So students, if you are asked to find LCM of numbers like this, you have to find the LCM of all the 4 numbers together. Then you have another method. That is the prime. You have to do, the prime factorization method. You will call it as the prime factorization method if you are going to the next standards. So the same thing we are going to do it over here to find the LCM. Okay. So what we are going to do is, first here I am going to place some number. That number should be a prime number. What it should be? It should be a prime number. Okay. So first I'll place 2 here because I know that 2 is a prime number. 2 belongs to prime number. So what I need to do is I need to divide 12 divided by 2. If I do 12 divided by 2, I will get 6. I have to write it here. Next I have to do 24 divided by 2. 24 divided by 2 gives me 12. Next I should do 36 divided by 2. I will get 18. Next, I need to do 48 divided by 2, which will give me 24. Again, let me take 2. This is also a prime number. I already told you that 2 is a prime number. So first I need to do 6 divided by 2, which will give me 3. Next 12 divided by 2, which will give me 6. Next 18 divided by 2, which will give me 9. Next 24 divided by 2, which will give me 12. Now, because 3 and 9 are not divisible by 3, 3 and 9 are not present in 2 table, right? So I will take 3. We know that 3 is also a prime number. So when I do 3 divided by 3, I will get 1. When I do 6 divided by 3, I will get 2. When I do 9 divided by 3, I will get 3. When I do 12 divided by 3, I will get 4. Okay? And still it is not completed. We have to resolve it in such a way that all the numbers which are left over should be prime numbers. Again I am taking 2 here. So because 1, we can write it as 1 only. Because 1 is not divisible by 2, we can write. Remember that at last all the 4 numbers which are here should become 1. Then only you will get the LCM. So if I divide 2 divided by 2, I will get 1. 3 is not divisible by 2. So I will write 3 as it is. When I do 4 divided by 2, I will get 2. Now again I have to make these two also 1, 1. So first I am taking 2. So that 1 remains same. 1 remains same. As 3 is not divisible by 2, I will write 3 also same. And if you just take 2 divided by 2, I will get 1. Now I am taking 3 here. If I take 3 here, 3 divided by 3 will become 1. So, as I told you, all the numbers have become 1 at the last. Now, to find the LCM, what I need to do is, here we have the numbers. Here we have all these numbers. We have to multiply those numbers to get the LCM. LCM is equal to 2 into 2 into 3 into 2 into 2 into 3, which will give me 144. So the least common multiple of 12, 24, 36 and 48 is 144. This is the least common multiple. I guess you are clear with this concept of LCM. So students, now let us move on to the next topic known as HCF. HCF full form is highest common factor. I already told you what is meant by a factor. So, HCF is also known as GCD or GCM. As I told you, this This HCF is also known as GCM or GCD. GCM means greatest common multiple. If you just see, I told LCM means least common multiple, whereas GCM means greatest common multiple. So GCD means greatest common divisor. GCD means greatest common divisor. So students, I already told you how to find the factors of a number. So the factors of 6 are 1, 2, 3 and 6. The factors of 12 are 1, 2, 3, 4, 6 and 12. So in order to find the HCF, highest common factor, first you need to write the factors of that particular number. So the question will be like, find out the HCF of 6 and 12. First step I need to do is, I need to find out the factors of 6 and I also need to find out the factors of 12 separately. Then what I need to do is, I need to circle the common factors. 1 is a common factor, 2 is a common factor, 3 is a common factor and 6 is also a common factor. So if you just see, HCF means highest common factor. Please understand highest. So I can write the common factors of 6 and 12 as 1, 2, 3 and 6. So which is highest here? 6 is the highest. So the highest common factor of 6 and 12 is 6. Okay, so this is how you find out HCF of two given numbers. So let me take another example. That is, let us find out the HCF of highest common factor of 24 and 36. So if you just see, the first step that you need to do is, you need to list down all the factors of 24 and 36 separately. So the factors of 24 are here and the factors of 36 are these. The second step is, you need to circle the common factors. 1, 2, 3, 4, 6 and 12 are the common factors of 24 and 36. So first I am going to list down the common factors. 1, 2, 3, 4, 6 and 12. So as we know, highest common factor is the HCF. So the highest is 12. Therefore HCF of 24 and 36 is 12. I hope that you are clear how to find out HCF and LCM of the given numbers. So students, now let us find out the HCF of 75 and 125. First of all, I need to list down all the common factors of 75 and 125 separately. So if I just see, I can write 75 as 3 into 5 into 5. And I can write 125 as 5 into 5 into 5. So if I just see the common factors over here, the common factors are 5 and 5. Now you might get doubt, what should we take if we get the same number? What you need to do is, you need to multiply them. So if I just multiply, I will get 25, which is the HCF of 75 and 125. So students, remember that whenever you get two same numbers as the highest common factor, you need to multiply them in order to get the HCF. Okay, understood? So students, now let us find out the HCF of 32, 48 and 64. First step I need to do is I need to list down all the factors of these three numbers separately. So I can write 32 as 2 into 2 into 2 into 2 into 2. Because I am writing all the numbers as 2, you can ask me that I can write 32 is equal to 16 into 2 also. Yes, you are correct. I can write like that also. But I prefer writing in prime factors form. So students, I can write 48 as 2 into 2 into 2 into 2 into 3. And I can write 64 as 2 into 2 into 2 into 2 into 2 into 2, which is 2 into 2 for 6 times. Now if I just see, after listing out all the factors of these three numbers separately, what I need to do is I need to circle the common factors. 2, 2, 2 and 2. So there are no other common factors. So you might ask me, ma'am, for 32 we have 2 and for 64 here we have another 2. But for 48 you don't have 2 here. So you need to take the common factors for all the three numbers. If you are given 4 numbers, you need to take the common factor for all the 4 numbers. Now, as I told you, if you get the same number as the HCF for many times, you need to multiply that number. I got 2 for 4 times. So 2 into 2 into 2 into 2, which gives me 16. So therefore HCF of 32, 48, 64 is 16. So students, the next topic that we are going to discuss is the divisibility rules of numbers. You might have learned this in your lower grades, but once let us do it as a recap for you. So first, let us check the divisibility rule for 2. So if you take 2, any even number is divisible by 2. That is the divisibility rule. Now, if you remember, already I told you what is meant by even number. So, if you have any number, any digit that is exactly divisible by 2, then that number is known as even number. Right. So, if any number ends with 0, 2, 4, 6 and 8, that number is considered to be even number. I already told you in the first class if you remember. So, if you just see here, for divisibility rule of 2, any even number is divisible by 2. You can simply remember that like that. Okay. So, now let me take an example. If I take 54, here 54 is a even number. Why 54 is an even number? Because it ends with 4 and 4 is also even number. That's the reason why 54 is even number. And if I check 54, 54 is divisible by 2 because it is an even number. So blindly remember that when any number is even, then that number is divisible by 2. So if I divide 54 by 2, I should check that the remainder should be 0. R should be 0. I will get 27 as the quotient and 0 would be the remainder for me. So I guess you are clear with what is the divisibility rule of 2. It is simply whenever whenever any number is even, then that number is divisible by 2. Okay? So next, let us go for the divisibility rule of 3. So if you take any number, for example, 96, then if you see here, if I add 9 plus 6, I am going to get 15. So 15 is divisible by 3. So this 96 will also be divisible by 3. So I will tell you one simple trick. If the sum of digits in a number, for example, I am taking 3276 as an example. Here, if you just see 3 plus 2 plus 7 plus 6 is equal to 18. Right? So 18 is divisible by 3, because if I do 18 by 3, it will be exactly divisible and I will get 6 as my quotient. So 18 is divisible by 3. We know that. So what you can conclude is the whole number is divisible by 3. You can also check that. Let us check that now. 3 2 7 6. 3 1s are 3. 0s are 9 3s are 27. 3 2s are 6. So I got the remainder as 0. I got the quotient as a whole number. So what you need to remember for the divisibility rule of 3 is, if the sum of the digits, if I add the digits in a number and the sum is divisible by 3, then that particular number is also divisible by 3. This is the divisibility rule of 3. So now let us see the divisibility rule for 4. I'll take an example as 164. If the last two digits of the number is divisible by 4, then the whole number is also divisible by 4. So if I just take the last two digits of the number, it is 64. Right? So 64 by 4 is equal to 16. Right? So it is exactly divisible, means the last two numbers of this 164 is divisible by 4. So automatically this whole number will also be divisible by 4. So if I just take 164, 4 4s are 16 and 4 1s are 4. Okay? So in order to be able to divisible by 4, in a number, if the last two digits are divisible by 4, then the whole number, however big the number may be also, the whole number will be divisible by 4. Okay? So now let us see the divisibility rule for 5. If any number ends with 0 or 5, then that number is said to be divisible by 5. For example, if I take 1050, here this number ends with 0, which means this whole number is divisible by 5. If I take 105, this number ends with 5, which means this whole number is divisible by 5. If I take 1000000000, this number ends with 0, so this whole number is divisible by 5. Okay? So whenever any number ends with 0 or 5, then that number is said to be divisible by 5. So children, now let us see the divisibility rule for 6. Let us see the divisibility rule for 6. Whenever any number is divisible by both 2 and 3, that particular number is also divisible by 6. For example, let me take a number 408. So if I just see, as the number is ending with an even number, that is 8, this is divisible by 2. 408 is divisible by 2. On the other hand, if I just add 4 plus 0 plus 8, which is equal, it will give me the answer as 12, which means this number, this 408, is also divisible by 3. So 408 is divisible by both 2 and 3. So 408 is also divisible by 6. Let us see whether it is true or not. 6 6 are 30. Okay. 36. 8 6 are 48, and the remainder is 0. So whenever any number is divisible by both 2 and 3, then that particular number is also divisible by 6. This is the divisibility rule for 6. So now let us discuss the divisibility rule of number of the digit 8. If you just see, I'll take an example for this. I am taking 53,888 as the example. And now the divisibility rule for 8 is, whenever the last 3 digits of a number are divisible by 8, then that whole number is divisible by 8. So as 888 is divisible by 8, because if we divide it by 8, we will get 111. It is exactly divisible. So when the last 3 digits, that is 888, is divisible by 8, so this whole number is automatically divisible by 8. Let us check whether this is true or not. So now I am going to take 8 6 are 48, where 5 will be the remainder. 58. 8 7s are 56. 2 will be the remainder. 8 3s are 24. 4 will be the remainder. Bringing 8 down. Again 8 6 are 48. So the remainder over here is 0. So students, the divisibility rule for 8 is, whenever the last 3 digits of a number are divisible by 8, then the whole number is also divisible by 8. Okay. So students, now let us see the divisibility rule for 9. So if you see, I will take an example. 639. Whenever the sum of the digits of a number, means 6 plus 3 plus 9 is equal to 18. When the sum is divisible by 9, then the whole number is also divisible by 9. So 18 is divisible by 9. So 639 is also divisible by 9. Let us check this. 9 7s are 63 and 9 1s are 9, where the remainder would be 0. So the divisibility rule for 9 is, whenever the sum of the digits of all the digits in a number is divisible by 9, this sum is there, no? When that is divisible by 9, then the whole number is also divisible by 9. Okay? So children, now let us see the divisibility rule of 10. Whenever a number, earlier I told you that whenever a number ends with 5 or 0, then that particular number is divisible by 5. Coming to the divisibility rule of 10, whenever a number is ending with 0, then that number is divisible by 10. For example, 5010. This particular number is ending with 0. So, this whole number is divisible by 10. If I take 103254689110, this number is ending with 0, which means the whole number is divisible by 10. Okay, so this is the divisibility rule for 10. So children, now let us find out the divisibility rule for the number 11. So for this I am taking an example. So I am taking the number 29,601. Here what we need to do is, first we need to do the placing. That is, this is the 1, 2, 3, 4 and the 5th place. So if I just see, first I need to find the sum of the digits in the odd places. Odd means here 1, 3, 5. These are odd numbers here. So the first one 2 plus, here if I have 3, right? So plus 6 plus in the 5th one we have 1. We have to write it as, so 2 plus 6 plus 1 is 9. Coming to the sum in the even places, so you have to take 2 and 4 because they are even numbers. So in 2, in the second place we have 9. In the fourth place we have 0. So again the sum is 9. What you need to do is, you need to subtract both of these numbers, both of the resultants. So 9 minus 9, because here we got 9, here also we got 9. So 9 minus 9 is equal to 0. Remember that whenever the final answer here, after this subtraction, you are going to get 0, or you should get 0 or multiple of 11. Now I already told you what is meant by a multiple, right? So whenever when you do the subtraction and the answer, the final answer is 0 or a multiple of 11, then this number will be divisible by 11. So here I got the answer as, the final answer as 0. So this whole number is divisible by 11. Let us check now. We can take 11 2s or 22. You will get 76, and you can take 6 or 66. 10. You can take 11 9s or 99. 1 is a remainder. We can take 1, where 11 1s are 11. 11 minus 11 is 0. So it is exactly divisible, because when you will tell a number as exactly divisible is when the remainder is 0. So here the remainder is 0. So 11 is exactly divisible by 29,601. Okay. So again I am repeating the rule for you, the divisibility rule for 11. First you have to find out the, if I take 29601, this is the first, second, third, fourth, fifth place. First I need to find out the sum in the odd places. 1 place, 3 place, 5, because they are odd. 2 plus 6 plus 1 is equal to 9. Then in the even places, 9 plus 0 is equal to 9. Now what you need to do is you have to subtract both of these. After the subtraction, the final answer that you are going to get should be either 0 or a multiple of 11. Multiple means if you just take 11, 11 multiples are 11, 22, 33. So if you get so on. If you get multiples of 11 or if you get 0 as a final answer after doing all these steps, then that particular number is divisible by 11. Sometimes for verification, you can do the actual division like how I have done here and also find out the whether it is divisible or not. But for if you are getting some bigger number, some 10 digit number, 15 digit number, that time you should proceed with these divisibility rules. So I request all you students to learn all the divisibility rules till 11, which are enough for your level. So thank you students. That's all for today's session. Meet you in the next session, and also you would be getting another worksheet. Please complete that worksheet, and you can just write it down in your notebook which you are maintaining. Thank you students.